Section 2.5, Equations involving absolute value. Absolute value property states that if the absolute value of x equals a, where x is a variable or an expression, and a is greater than or equal to 0, then x would equal a, or x would equal negative a. So you can see we're going to end up with two answers with absolute value equations. Now, what does an absolute value really represent? It represents the distance. That number is from 0. So we're looking at a distance, and a distance can never be negative. Keep that in mind. So, how do we solve an absolute value equation? Well, the first thing you want to do is isolate. Always isolate first. Get the absolute value by itself. At that point, you're going to need to write two equations. Why? Because you need two answers. So write two equations. First one is, you're going to drop the absolute value and just solve the resulting equation. The second equation is, you're going to drop the absolute value, but you're going to place a negative on the right-hand side. So those are the two equations, and therefore you'll get two answers. Lastly though, check your answers. Always check your answers. And the reason being is because an absolute value cannot be negative. So sometimes you're going to get possibly some answers that don't really work. So make sure you check your answers. So let's solve. Number 1, the absolute value of x equals 7. First things first, isolate, but it's already isolated. Second thing is, you need to break it up into two equations. So I like to do these arrows, so I end up having two equations. First one is when I just drop the absolute value, and I get x equaling 7. The second one is when I drop the absolute value, but I put a negative on the right-hand side. Looking at both of these equations, they're already solved for you. So I know my two answers are 7 and negative 7. Let's check to make sure they actually work. So the absolute value of 7 is supposed to be 7, and that's true. And the absolute value of negative 7 is supposed to be 7, and that's true too. Why? Because both 7 and negative 7 are 7 units away from 0. So now let's look at number 2. 2 plus the absolute value of 2x minus 6 equals 10. First thing we need to do is isolate. So we're going to subtract the 2 on both sides. We'll end up with 2x minus 6, close the absolute value, equals 8. At that point, we're going to need to break it up into two equations. The first equation is when I just drop off the absolute value. So 2x minus 6 equals 8. Second equation, I drop off the absolute value, but I put a negative on the right-hand side. So negative 8. Then I'll need to solve each one. So for the first one, I will add 6 over to the other side. So I get 2x equaling 14. I'll divide by 2. So x is going to equal 7. On the other side, I'm going to add the 6. And I'll get 2x equaling a negative 2. I'll divide by 2. So x is going to equal negative 1. We're going to check to make sure both of these satisfy the absolute value equation. I will check x equaling negative 1. You'll need to check x equaling 7. So here's the check stage for x equaling negative 1. Plugging it in, I get 2 plus the absolute value of 2 times negative 1 minus 6, close the absolute value, is supposed to equal 10. So we'll put a question mark. Let's make sure that's true. So we end up with 2 plus the absolute value of 2 times negative 1 is negative 2, minus 6 is negative 8. Close the absolute value, equaling 10. Does it work? Yes. We have the absolute value of negative 8 is positive 8, and 2 plus 8 is 10. So I'll let you check x equaling 7, but it should check out as well. Number 3. The absolute value of 4/5 x minus 5 is supposed to equal 10. So the first thing we need to do is isolate. So we'll need to add 5 to both sides to get the absolute value by itself. So the absolute value of 4/5 x minus 5, close the absolute value, is supposed to equal 15. Now at that point, we are going to separate it into the two equations. The first equation is when we have 4/5 x minus 5 equals a positive 15. And the second equation is when we have 4/5 x minus 5 but equals a negative 15. So now we're going to solve this equation like we did in the previous section. First thing to do is add over the 5. So we end up with 4/5 x equals 20. Again, you can decide how you want to get rid of the fraction. I'll show one step at a time. The thing we want to get rid of first is the dividing by 5. So I'm going to multiply both sides by 5. When I do so, multiplying by 5 but dividing by 5 just gives me a 4x. And 20 times 5 is 100. At that point, we'll divide both sides by 4. So we're going to end up with x equaling 25. For the other problem, I'll come up here so I have a little bit more room. So first things first, add the 5 over to the other side. That's going to give me a 4/5 x equaling negative 10. Again, you can decide if you want to multiply by the reciprocal. I'll go ahead and show one step at a time. So I'll need to get rid of dividing by 5, so I'll multiply both sides by 5. When I multiply by 5 but divide by 5, I just end up with a 4x. And negative 10 times 5 is a negative 50. At that point, I will need to divide both sides by 4 to get the variable having a coefficient of 1. So x is going to equal negative 50 over 4. I'm okay with you leaving it as an improper fraction, but you definitely need to reduce. So a number that can go into both of those is a 2. So I'll end up with a negative 25 over 2. Both of these answers will check. I'll leave that up to you to do. So let's do number 4. The absolute value of x plus 5 plus 10 equals 4. Again, the first thing I need to do is isolate the absolute value. So I'll subtract 10 on both sides. So I'll get the absolute value of x plus 5, close the absolute value, equals negative 6. At this point, I'll need to break up my equations into two different ones. First one is when we have x plus 5 equaling a negative 6. The second equation comes from dropping the absolute value, but placing a negative on the right-hand side. Since it is already a negative 6, placing a negative over there would make it be a positive 6. At this point, I need to solve. So I'll subtract 5 on the left, subtract 5 on the right, so I get x equaling negative 11. On the other side, I'll subtract 5 as well, and 6 minus 5 is a positive 1. So right now, it looks like I have two answers of negative 11 and positive 1. But we did say we should always check our answers. So let's check x equaling negative 11. Checking x equaling negative 11 into the original, we get negative 11 plus 5, close the absolute value, plus 10 is supposed to equal 4. Well, that gives me an absolute value of negative 6 plus 10. Well, absolute value of negative 6 is positive 6, and 6 plus 10 does not equal 4. So x equaling negative 11 does not check. Well, let's check x equaling 1. Again, going back into the original, we're going to have the absolute value of 1 plus 5, close the absolute value, plus 10 is supposed to equal 4. 1 plus 5 is 6, and the absolute value of 6 is 6. 6 plus 10 does not equal 4. So that answer does not work either. So therefore, since neither answer works, I have a no solution. Now, could I have known that before I went and solved the whole problem? You could at this point. Once you isolate the absolute value, and you have that the absolute value of x plus 5 equals a negative 6, you know that can't happen, because at the very beginning of this section, we said that the absolute value had to be positive or 0. So therefore, we knew that that would be a no solution. However, if you don't understand how that works, definitely just check your answers, and you'll see that your answers won't check, so therefore you do get a no solution.